Okay, so looping, or loops, is a special mechanism in programming that is something that you encounter in your real life, in the real life too, right? Something that you repeat over and over again for a number of times. So in programming, we have, especially in Java, we have 3 kinds of loops. Actually, there's a 4th one, but we'll get to that later when we learn arrays. So there's the while loop, for loop, and the do while loop. And we'll look at those, what they mean, and how do you use them in your code, and why you use them, and why they're important. Okay, so it's almost impossible, I should say, to write a really good program without, using one of these loops. You can use different mechanisms to achieve the loop by using function calls, but you see that with these loops, it makes your life much easier and much simpler. Question?
Yeah. You just want the method header, right? For the one about overloading.
Are you talking about the exam?
Yeah.
Yeah, I don't ask. I don't think you need to remember about it. Yeah. Okay. So a loop is a structure, right? Allows repeated execution of a block of statements. So in the real world, it's like, like when you leave the house, right? You leave the house, you go to your car, and you realize that you forgot your keys, right? So you go back to the house, get the keys, and when you get to the car, you forgot to turn off the AC or something like that. So you go back and forth many times until you have everything taken care of, or you can just say, oh, you know what, I don't care about the AC, I'm just going to take off anyway. Then you can stop the loop prematurely. You can do that in programming as well, and I'll show you some of those examples later on. Okay, so is a structure that allows repeat execution of a block of statements. Okay, it could be just one statement, it could be a lot of them. Within the statement here, you could branch out to other functions, other programs before coming back. So wherever you branch out of, chances are you're going to come back to where it was to finish the loop. Okay, so you can terminate the loop prematurely if you want to, if you have to. Sometimes you have to, and I'll show how that's done. So one execution of any loop is called the iteration or one cycle. These are just some terms that you hear of often in the programming world. One iteration, that's what it means. A loop can run definitely and definitely, or these two are kind of similar, infinitely. Okay, it means forever, right? So we have those like a run on loops or forever loops. Okay, so be very careful with those. Those can kill your program if you are not careful. And those are really hard to detect sometimes. Sometimes you won't catch it until during execution time. So. Okay, this is the loop structure of the flowchart. It looks just like the if and else branch last time we saw, except now if you follow the arrow, it cycles back to the beginning of this expression again. Okay, so this part is the loop. It forms that loop here. You see that some diagrams they put a dash, a circle right here with a dash. It just means just cycles go round and round until the loop or the execution is false. Then it will exit the loop. So make sure you have a way to exit. Otherwise, you run into that infinite loop or that forever loop. Okay? So this is a very a simple, typical loop structure. These are just some key terms. We have something called the counted loop or the definite loop. This is how you measure or control the loop based on how many iterations or how many rounds that loop cycles through. Okay, and so this is called a counter control because you have a counter to control that loop. The counter will be just any variable to stop the loop, to make the condition false. If you don't do that, then the loop will run forever, right? So we'll do some example of that, and that is the indefinite loop here. This is the loop that runs forever. Sometimes it's also called the event-driven loop because, again, it needs to get some data from somewhere to terminate the loop, especially when you read a data from the user. So you write a program to accept a user input, then that will you will read that input and you test that input value against another condition, make sure that it's a valid or invalid value, and you can stop the loop. So that value that you use to test is called the sentinel. Okay, it could be anything. Sometimes you might ask the user to enter a series of numbers, and then they say enter a -1 to stop the loop. Okay, when you're done, press or type -1, or type X, or type QQQ, or type 999. It doesn't matter. Whatever that is the terminating value. So that is called the sentinel. Okay. Another term you will see is prime or priming, or sometimes called priming read or priming input. It just means how you initialize your counter, right? You have a counter, you initialize it so you can start the loop. Okay. So in a loop, it's usually very common to have a counter and a accumulator to accumulate some data. Okay. Especially if you are doing some arithmetic operations. So we have what's called a loop, a top control loop or a pre-test loop. This is usually applies to while loops, and the while loops are called top controlled or pre-test because you would test the loop condition at the top of the body of the loop. Okay, let me make this a little bit smaller. And so you see that this is the while loop here. You test the condition at the top, and if that is true, then you go into the body of the loop, and then you keep going until that cycle is false, and then you exit out. Okay, so you test the condition first before you run the statements. So this type of loop is sometimes it does not guarantee any iterations in the body of the loop. Okay, because you test the condition first. If that condition is false initially, then there's no way to run the body of the loop. So it doesn't guarantee any iterations. Okay, so all pre-test loops are like that. So a while loop is a top controlled or pre-test loop. Yeah, that's just a while loop. I'm going to go into the next one. This is a do-while loop. Okay, do-while loop looks kind of similar, except this is the bottom controlled loop or the post-test loop. Okay, so you test the condition after you run the statements of the body. So again, the placement of that diamond shape is where the condition is being placed, right? So it's at the bottom. So you stop on the top, you run the statements or whatever is inside the loop one time, guaranteed, and then you test the condition at the bottom. If the condition is true, then you go back and cycle through the whole loop again until it's false. Okay, so the bottom controlled or the post-test loop guarantees one iteration. It always guarantees it because there's no test. You just run through one time. So that's the major difference between the two. And then the other one is a for loop. This one here works very similar to the while loop. This one we always test at the top, okay? But the structure is a little bit different. When you code it, it looks a little bit different. So you always have a choice between a while loop and a for loop. Okay, so you will see that in many articles, readings, or many tutorials or lectures, you will hear they say that if you know the boundaries, the upper bound of your loop, then usually you use the for loop. If you don't know the upper bound of that condition, then you use the while loop because you don't know when is it going to stop. Okay, like for example, if you're going to read some input from the user, you don't know when it stops. So in that case, you use the while loop. It's more efficient. But if you know a finite number of loops through the iteration, like later on when we learn about arrays, they has like 10 number of elements in the array, then you know the limit already. In that case, the for loop is the better approach. Okay, so look just like the while loop. You test the condition and you run through the body of the loop until that condition is false, and then you exit out of the loop. Okay. They should be very similar. And that's the syntax. We will talk about that later and see if there's anything else I want to show you. Okay, we'll come back and revisit this again. Some of these like unconventional for loops, a little bit tricky, but useful sometime. You won't find this in a lot of programming code. It's not very popular, just that you can do some of these. Okay. Let's see what else I want to show you. You can also nest your loops inside other loops, just like the if and else block switch cases, like those, right? You can also put that inside each other. And then sometimes you have to do that, especially if you are traversing or iterating through a table, right? Or two-dimensional arrays. You have to use a nested loop, otherwise it won't work. Okay, that sometimes it's required, but you can have nested loops. And again, it doesn't have to be the same type. It could be the outer loop here is called the outer loop, the outside one. It could be the while loop. The inside loop or the inner loop could be a for loop, right? Or vice versa, or it could be the same. So it doesn't matter what kind of loop it is, depending again, what are you trying to loop through. Okay. The caveat is that your inner loop must be completely contained within the outer loop. So you can't have like half inside, half outside. Okay, that's not allowed, and you have a syntactic error if you have it that way. Okay, this is where you would force a premature exit out of the loop by using the break keyword here. Other languages might use a different word, might use exit, but Java and most languages use the keyword break. If you supply the keyword break here, it will cause the loop to stop or terminate prematurely. Like I mentioned to you a while ago about driving away with the key in the car, and you say, oh, you know what, I don't care about the AC system, let it run, I'm just going to take off. So you prematurely terminate the loop, right? So you can do that, and sometimes you do that. Like if you want to look for a list of numbers between 1 and a million. So you don't want to go through the whole million numbers, just look for the number. Once you found a number, wherever it is, it could be the third number, it could be the 100,000 number. Once you found it, then you can exit the loop. You don't have to worry about the rest of the numbers anymore. So that's when you will use a break to terminate that loop. Okay? Okay, these are just some pitfalls. I just grabbed this from the book. A little bit tricky, so be careful with these as you go through them. All right, so let's go into the code and do some examples. I'm going to create this Unit 6 project. The screen's so big here. Alright, I'm going to create a package. I could just call it the ch6 dot, let me all lowercase, ch6 dot loops. Okay. So let's create a program class. I just call it loops with the main method and create. So here is our typical application. Okay, well, before we do the loops, I want to show you how you can actually create loops using functions. That can be done too. If you remember, if you ever done any procedural coding programming in the past, some languages allow you to go back or have a go-to statement. You can go to a different label, and you can jump back and forth. By doing that, you're actually creating some sort of loop. Okay, so let's write two functions in here, and we're just going to say, like, kind of illustrating our example from the beginning about going to the car and drive away or go home, right? So we have a function, static function. We're just going to call it void. We're not returning any data. We're just going to go ahead and do it, right? So let's just say this one here, go to car. I'm going to put like that. Go to car. Okay. This function goes to the car. I'll write another one down here. Just say go home. Okay. And then maybe you just write a third one, just to make this a little bit more fun. Just say drive away. Okay, so here's our loops, right? You could make that into a loop. And in the main program, all we have to do is we will just start the initialization of this program by calling the go to car. Okay, so let's just say we're going to go to car. We call that. So we're going to go to the car. I mistyped that. Too many T's. Okay, so when you go to the car, we can check if we have the key, right? So usually you say you check if you have a key or not. And we'll put a key up here in the global space, so it's accessible. So let's put a variable up here, a static variable. We'll just put a Boolean type, either has key, right? We'll make that initially to false. Okay, and we'll check the key. If you have key, if that is true, then drive away. Otherwise, you go home, right? So that's from the if and else block from last week. So we can say if has key. Okay, this is, if you just leave it like that, that's completely fine, because this is a shortcut for this, right? So it's because it's a Boolean, it will evaluate to true or false by just putting that keyword or the variable there. You don't have to type this in here if you don't want to. That means that you expect this to be true if has key, because that's also why it's common to have your variables named this way, so you read it, it makes sense in a sentence. If has key, then drive away, right? And if it has key, then drive away. If it's not, then go home, right? So you can put else here. This would be go home, because we don't have the key yet. We forgot the key. And then this is, if it's true, then we're just going to drive away. Okay. So that is the task. You go to the car, you check, oh, I forgot my key. I don't have the key. Then I'm going to go home, go back to the house, and get the key. Okay. So once you get to the go home, we'll just do very simple for the key. And then we're going to get the key. So you could write a function to say get the key, but we'll just stop here. We'll say, oh, has key is now true. Okay, so I set the has key to true. After that, I got the key. Then I go to car, right? I call go to car again. So this is what the loop occurs. Okay. If I go to car, if I have the key, then I drive away, then the loop terminates here. This is terminating the loop, right? This one here goes to home, and home goes back to the car. As you can see, it calls a function again. So you form a cycle around these two functions. So this is the loop. Loop here, it loops here because it goes back to the car. If the key is false. If you don't set this to true, if you leave that false, it's going to have an infinite loop because it will always be false. So therefore you run into that loop of death, I guess you want to call it, right? it's going to kill your system and it will shut down your system. Okay, so you want to avoid that. But in this case, it's going to be really simple. And we'll put a message down here. Says, so we know, right? Sys out. Got key. Okay. And then down here in the drive away, we just put another message saying driving away. So we know. And then down here we don't have the key, so we could output forgot key. And then let's say heading home, right? So we know it's going back home. And then once we got the key, and the key is true, then we could put a message here. Say got the key. Head back to car, right? So we know that I'm going to the car. Okay, so that's it's like a little game already if you think about it. And here, just really simple. Once you go to the home, you can do a lot of stuff inside here, right? Get the key, check the AC systems, turn off the lights, make sure you lock your door, all the stuff. All right, so if you run this program, hopefully there's no bug. I did not test it. We did not do any error checking. As long as we know there's no syntax error, so that's a good sign. But it's possible that might have errors. We might run into a loop. So let's run and try. And it'll be very fast, so you probably won't see anything, happening like slowly. But you see that it works, right? So we forgot the key initially. We're heading home, and we got a key. Then we go to the car, and then we got the key. So now we drive away. Okay. So that works just fine. Let's see. One thing I want to do is, let's see here. Hello. Okay, you can put a thread in here. Just to kind of show you the thread. We're not going to learn in this class, but a thread is allows you to force a sleep. It's like a pause. Because when you run this Java program, it runs on a thread. Okay, a thread is like a, if you're familiar with parallel programming, you have multiple sessions running at the same time. Okay, so when you create your Java program, you always have a default thread that runs your program. So that is issued by the thread. And so if I go ahead and import this, or actually surround this with the try catch, again, we'll deal with this later on. For now, I'm just going to do that there. So I'm going to pause it for at 1 second, 1,000 milliseconds. That means 1 second, right? Maybe we can make 2 seconds here. Okay, again, if you type thread.sleep and you put 2,000 in there, you have that red line, like here, thread.sleep, and you can put 2,000 milliseconds, and it has the red line because you have to check this, try and catch this. Again, that's for error handling. We'll deal with that later. So just mouse over that and add the surround with try catch or add throws declaration. It doesn't matter which one you use. If you add a throws declaration, it's going to add that to your function. If you don't do that, you're going to wrap it with a try catch. So you can choose either one. I'll just use this try catch here. And let's see, we put a pause here for 2 seconds. We'll put a pause out here for 2 seconds. And let's put one more when we go home. Okay. So thread again, dot sleep 2000. And surround that with try catch. So if I would separate this, we can see a little bit better. It should still be the same as before. I just put a throw that sleep in there, so it will pause for 2 seconds before it runs the next command. Okay. So now, if we run the application, hopefully it will pause. You can see that it forgot the key. It got the key. It head to the car. I got the key. And then you drive away. Okay, so you can pause like that for a number of time before you start execution. So you can see it. Otherwise, it's so fast you don't know the actual steps involved. And sometimes if you want to see how things flow, then you put a thread sleep in there, so you can control the flow. Or if you don't want to use the sleep, you can put an input in here, right? So read from the inputs. It will wait until the next input, then we read the next line. So that's another option too. All right, so this is a good loop because it doesn't repeat itself for a indefinite time. Let's make this a loop that goes forever. Okay, that is by going to the home down here. Go home, and we'll make this false, or you just don't check it. You just comment that hash key out, and you didn't update the hash key value, so it'll always be false because we initially had it false on the top, right? Way up here is false, so it will always be false. And if you run it now, you see that it will loop forever. Okay, forgot key, head home, got the key, go to the car, forgot key, head home. So actually, you don't really got the key. Okay, this is not, because we just put it that way. So it will go forever until the system resources is completely run out, and then it shuts down your program. Okay, so in coding, and if you're using this IDE, NetBeans also is the same thing. You have to stop it, right? You can stop it by clicking this red button here to terminate this loop. Okay, if you don't do that, you have to either close Eclipse or sometimes force a shutdown. Okay, so it's nice that these IDEs give you that capability to stop your infinite loops. All right, so what we just did was we can actually create loops using function call. In other language, you can do a call like goTo. Instead of goTo cars, you put a label in front, and you go to the label, and it jumps back and forth. So again, it's almost like a game. Okay, so now let's write a loop that kind of do the same thing, except now you don't have to use functions. Okay, so let me just comment this out so it doesn't call that function anymore. And inside, let me just move this way down here so you can see it. This is our main function. So let's go with that while loop first. Okay, a while loop, this is a pretest loop, or a top control. Okay, so make sure you know what those terms mean, because that'll pop up on the exam. Again, the top control is you test the condition at the top. So the syntax is you write the word while, followed by a pair of parentheses. This is where you put your conditions in here. Okay, and then you wrap your body of code inside a curlies, like this. Okay, so you're saying while this condition in here is true. Okay, if it's true, then go ahead and run the statements inside a while, the body of the while loop. So notice we don't have the word loop here, so don't put loop here. It doesn't work that way. Okay, it's just while. And the condition will be like, for example, we can say while has key. Same thing, right? While the key is true, this one's saying. While the key is true, go ahead and do the following. Okay, if you do this, just to show that what the loop does, we can just put a message here, sysout, S-O-U-T, right? Shortcut. If you haven't known that, it's S-O-U-T, control spacebar. Again, that's only for Eclipse. Other IDEs is different. And then we'll put message here, I have the key, right? And if you save and run this program, you will see that nothing should be printed out. Okay, there's nothing to print out. I don't have anything to print out, so you don't see in the console, but it's nothing here because this is not true. Okay, it says while the key is true. This is again same as saying while key is true. As long as this key is true, then keep running this statement. Well, we checked it, it started with false. So therefore, this statement did not get run. So therefore, we say top control loop does not guarantee a iteration in the loop. Okay, because like in this case, if it doesn't meet the condition, then you never run this loop. So that is what happens. Now this is a very, be careful when you do this kind of loop. You could test a true or false boolean here, because the only way to get out of this loop is this has to be false. Okay. So this is sometimes not very favorable, but again it depends. So in here we can say we'll make it so that well I don't have the key. Okay, so we say well the key is not true, right? Well, the key is not true. That's again a lot of ways to write it. You can say not true, or well the key is equal false, right? Same thing, not true. Or you can do it this way, while has key, but you put the exclamation mark in front of it, that means not. We talked about that last time. This is the not operator. It will reverse the Boolean value of this key if it's initially is false. And then, well, we would check for true. We expect to be true, but we negate that, so it's false. Okay? So it's the same thing. So we'll say, let's just pick this way so it's easier to read. Well, the key is false, then do the following. And we'll get, maybe we'll read something from the user, right? And we'll say, so let's go up here and do a scanner, the input scanner. So we're going to read an input from the user. We're going to get the key. So make sure you import the scanner. And we'll read that from a keyboard into a string. Just put key here. So we're going to say input dot next line. So we expect the string to come in. And let's just put another variable up here that we want to test against, right? So put a variable here. The key, maybe like a keyword or something, is, I don't know, we'll just put a key in lowercase. Okay, so that's the keyword. So the keyword has to match the value key. So we got the user from the input, or read from the input, read from user, or console, right? then I'm going to check the key against the keyword up here. If it matches, then we'll set the key to true. So we'll exit the loop. Otherwise, we'll keep going through the loop until we get the matching key. Okay? So remember that if you do this, if key equals the keyword, right? Be careful with this. I'm showing you here the incorrect way, okay? Because I'm comparing two. Every time I want to read a data from the console to a variable called key, if it's a string, I'm trying to compare two strings against a keyword here. Doing this way using the double equal operators will always be false because I'm comparing the memory addresses of these two variables. So they will never be the same. So in this case, it will always be false. Okay? So we'll fix that. Just to show you again. So if that is true, if they match, then we want to say the hash key value is now set to true. Okay? And we'll move this message inside here. Okay? Because now we have the key. Else, if it's not true, then we'll say I don't have the key yet, right? You can say like try again, like usually. So in this case, I have a variable to check the condition, and this variable is actually the hash key. And I'm reading from the user to match that keyword up here. They have to match. Once they match, then it'll be true. And once this is set to true, I would exit the else part, comes back to the bottom of the loop, nothing more to run. It reads this brace right here. It goes back to the beginning of the loop again. It will check the condition. Is it still false? Not anymore because it's true now. So at that point, it will exit the loop and it will go down here to line 26. And we'll put a message down here to show it, to say done or completed. So we know that it's outside of the while loop. Okay, so if my intuition is correct, this will never be true, and therefore we will never finish this loop. Okay, I mean, it will keep asking for the key, but it will never be true. Okay, let's just run it. Okay, let's do one more time. I forgot to put a message here, so I don't know what to input. So right above here, put another message. Enter a key. Maybe a keyword or something. Like the keyword. We'll put a print, not a print line. So we'll know. So we'll prompt the user. Okay, so enter a keyword. If I put in key, match exactly the keyword. Okay, you see that it says I don't have the key yet. Enter a keyword. And I keep doing that until I find the key. Okay, so be very careful when you do this because this will be an error. It's a logic error because there's no syntax error. It's not a, there's no runtime error. It's just a logic error. Okay, your program doesn't crash, right? And you keep doing this until you just force it to terminate because you can't stop it. So it really, you go into an infinite loop. Okay, so let's terminate this. To make this work, remember if you're reading a string and compare it to a string variable like this, you have to use the method call dot equals, and then you wrap the other string inside the parameter here. So you pass the string, which is the keyword, against this keyword you read from the user. If they're equal, then this will be true, and then we're out of that loop. If it's not equal, then we're out of it. So when you use the equals function to match it, now you're not comparing the actual memory addresses, you're comparing the actual value, which is key, against the key from the console. So let's run again. Again, put a uppercase K, it won't match because it doesn't match the lowercase, right? Case is important. And now if I put in lowercase key and I have the key, I'm done. Okay, so that's how you terminate the loop. It's just to make sure this condition must be set in such a way so that you are able to exit out of the loop. Okay, the other way is to force a premature exit out of this loop. To do that, maybe you could say after 3 tries. Okay, after 3 tries, if the key has not been found, then we'll just force an exit out of this loop, so we don't have to go forever. To do that, we have to put a variable outside the while loop. So this is like the counter. Okay, you have a counter to count how many iterations. So let's put an integer here, put count. We'll start with 1. Okay, and then we'll check the keyword here. When it is false, I don't have the key. So we'll do here, we'll say if the count is greater than or equal to 3, or maybe greater than 3, right? Greater than 3, depending on how you set here. If it's 0, then greater than 2, but if it's 1, then we're greater than 3. If that is the case, then we'll just cause a break. Okay, this is a premature loop termination. Okay, so you cause the loop to stop at a certain number of times. We just happen to choose 3 times. Okay, when we enter 3 times and they don't match, A, B, C. And then the D time, this will be the 4th time already because I have more than that already. As long as it's not going. Okay, I probably did something wrong. Yeah, so I have an error here. Again, it's not a logic error. I'm not sure if you catch it, but why didn't this work? I did it 4 times, and I keep doing it. It should stop after the 3 tries. Okay, this is one of those gotchas, and you will miss this probably even the first time you write it. It's very easy to miss, especially with the while loop. Sometimes it's not recommended because of this issue, right? So you run into an infinite loop. And the reason was because this counter will always remain at 1, right? Always remains at 1. Yeah, I did not increment 1, the count, so it will always be false. That is why. So once you run it once, down here at the bottom of the loop, it's always the safe place to put. If you put it inside here or inside here, it may not work. So if it's guaranteed to be counted, then you put it down here. So you put count plus plus. Okay, to increment that through every iteration. So don't forget the counter. This is now it's like it works as a sentinel also to terminate the loop because it does it indirectly. Okay, but your direct loop termination variable is still the hash true because it's inside the block here. Okay, so again, while loop usually has a counter. If you're using a counter, if not, make sure you update one of these. So let's run again. Now if I do again A 1 time, B, C the 3rd time, and then this is now more than 3, and then it exits out. Okay. So you terminate the loop prematurely because this has not been met yet, but I force the exit out of that. Okay. So sometimes you do that. Again, for whatever reason you want to do it. Okay. And this is very useful for like when you have a user log in. After 3 tries, you lock your account. Right? Exactly the same. Get home? Okay, have a good one. Okay, any question on the while loop? Okay, this condition here, I just make it very simple. It's a true Boolean type. You could make this, I could put a count in here, right? But if you do the count, then you can put both of them in here. So in other words, I don't have to put that break here if I don't want to. I could just comment this out, for example. I mean, again, the neat thing about programming, right? Lots of ways to do it. I could use this test inside part of this condition, because when either this is true or this is true, then I'm done. Okay? So you can put a compound condition inside the head of the loop here. So I can say this is one condition, has key equals false, and I'll use the 2 pipe symbol for or. Remember the short circuit or when count is greater than 3. Okay, so when you do that, then it will force the while loop to terminate. In that case, I don't have to put that down here, because it's going to go through the loop 3 times anyway, and after 3 tries, if I haven't found the key, then it's going to terminate the loop anyway. So if I run it again, it should still work just like before. 2, 3, and the 4th try should fail. Oh no, yeah, another error I made. Okay, another error. Who spotted? What's the error? It doesn't terminate. What do you think? I mean, I didn't have any syntax errors, but it keeps going forever. It did not terminate the loop. Yeah, this is like one of those tricky ones. So I terminate down here. Down here.
Oh, down there.
Mm-hmm. The else, just that I don't have to keep. This is commented out.
Okay. You're outside.
No,
That's
I'm
the
inside.
problem with the way we do this braces. I can never figure out which one's better.
Yeah.
Which brace matches the wild. I usually put a little comment after it says.
Yeah, this one down here. This is the while loop.
Second. Oh, okay.
Yeah, that's the while.
Okay, so we're inside the wild.
Mm-hmm. I have a string here. Let me just move it.
Then count after. So after 3 failed attempts, you should
Mm-hmm.
go forward.
Yeah, this is going to be one of those really hard to catch.
Okay, while has key is false, or
Yeah,
has key is false.
Yeah, it initially is false.
It is false.
Mm-hmm.
Either one of those is valid.
Mm-hmm. Right.
Has key is false. So you're not typing them right.
Right, I'm not typing the right key. And after 3 tries,
So
since
key is always going to be false. So that matches or not greater than false, but double bar is forward.
Getting close.
While as key is false or count is greater. Count less than
Count less than 3.
keep looking while as key is false or keep looking when count is greater than 3.
After 3 tries. After 3 tries, or when I found the key.
Yeah, if you're saying or not.
Yeah, I think you got that.
As key is false if you haven't been the right key. So
Right.
always, so now you're trying to stop them after 3 bad answers.
Yeah.
Count will become greater than 3. But as key is still false.
Yeah, I think
Yeah,
you got.
so as key is false and count greater than 3.
Right.
Yeah.
So this has to be and.
Whenever.
Okay. It cannot be or, because this will always be true regardless of this one here. If it'll match the key. Right?
Correct.
If it's false, then yeah, it's always going to be false. And this may be 1,000, that doesn't matter. Okay, because of this or. So if you make it an and, that means both have to be true. Yeah.
You see, I normally would put my count inside of what I'm testing for, so I want to see 3 wrong answers based on doing more things at the time. I was testing. You didn't get it right 3 times, and you're not sure what about doing more than just false.
Yeah. So right.
Test, say,
Yeah. So but once you do that, it should still be false, right? So again, it's tricky because the way I did it here. And this will still be false, because if you think about it, count is greater than 3. It's not. Initially, it's not greater than 3, so it's already false. And so in that case, you will never get executed inside the code.
yeah, so we're back to count.
Yeah. So this will be right. Go back to less than 3. Okay. When you reverse the sign, you also want to reverse the sign here. That is the trick. Okay. So now it should work. 1, 2, 3, 3. Well, only 2 because we put the less than equal sign. It's not inclusive now. Inclusive would be like that. So 1, 2, and 3, and then it fails. Then we're done. Okay, so it's just very tricky. When you change the sign from and to or, make sure you also change these signs, the reverse of that, to make it equivalent. Okay. And if it's confusing, then that's why I always break this out into a smaller sub loop or a nested loop. You test one at a time. If this is true, okay, well, it's true, good. Inside here, you do again, while count is less than 3 or something. And you run that again inside. Okay, let me do the other loop, the do while, and then we'll take a break. Now the do while loop works almost exactly the same as this. The only difference is we just inverted the loop condition to the bottom instead of the top. Okay, so for example, let me copy this. I want to keep this as is, and let me comment these out, and I'll put above here. This is the do while. This is a post test loop or a bottom controlled loop. You test the condition at the bottom. So how you do that is kind of very similar. So all you do is you move this line, okay, to the bottom here, down here of that loop. And in its place, you put the word do. Okay? So it's called the do while loop. So you move the condition to the bottom And because of that, I have to put the semicolon there. So here is our do while loop. Because do while loops are bottom tested, you'll see that there's no condition to test here, so therefore these will run at least once. Okay? One time. Always. And then at the bottom we'll check the condition down here. If the condition is met, that means if it's true, if it's still true, then we'll go back to the do part and we'll repeat that again. Okay? So if you run this again, and then, so here we have the enter a keyword. So put again for 1. I don't have the key, enter a second time, and then a third time, and then we finish the loop. So it works exactly the same as before, except now you guarantee it one time. Even if I put here like true, or this number could be like a 0, it doesn't matter. Okay, this is false already, and this is count is 1. It's not less than 0, it's false, so this will be false. So therefore it should not continue. But because it's in bottom tested, you will run it through it one time, as you can see here. Okay, because there's nothing to check up here until the end of the bottom of that loop. So you put it in here, and it will terminate the loop because it's no longer true at that point. Okay, had I had this before, then this loop, this body will never run, right? Because it's already false from the beginning. So that is the major difference between the two, the while loop and do loop. And there are sometimes you want to use this way because you don't know what the condition may be, but maybe you want the user to do something. Maybe you want to set some you want to initialize some data before you actually run the program. So you use a do loop. Okay, so you set the data first, and then you ask the user to do something. So it always guarantees to set or run some statements. So you use the do loop instead of the while loop. And sometimes you just hear the term do loop. You may not hear the term do while loop. You just do loop. Okay. And this is the while and do while loop in Java. If you were a Visual Basic programmer, you have another loop called the until loop. Okay, do until and do while. A lot more, but